Okay, Honors Algebra 2, we are going to do the last lesson of Unit 5, Solving Radical Equations and Inequalities. So here we go. We are on page 10. When we first started solving equations in Algebra 1, and hopefully before that, we solved for x by isolating the variable. As we have progressed through Algebra 2, so far we have had different types of equations where we continued to isolate the variable. When the variable is squared or when the variable is an exponent. So practice, let's solve these two equations just as a review. So we want to isolate our variable, which means, excuse me, we're going to add 8 to both sides and get 3x squared equals 15. We're going to divide by 3, so we have x squared equals 5. And then we take the square root of both sides, so x equals plus or minus square root of 5. And there we go, we isolated the variable. Over in B, we want to isolate our x again. This one might be more challenging to you. It's a better review problem. We're going to subtract 2, so we get 5e to the x equals 6. Then we are going to divide by 5, so e to the x equals 6 divided by 5. And now the way we isolate our variable is we use our logs, remember? So we would just rewrite this equation in log form. Now remember, you can only do that when your e to the x, or whatever exponent base to the x, is isolated. So how does that work? You write the ln. It's the ln because it's a base e. Basically, this would be log base e of 6 over 5 equals x. But log base e is the ln of 6 over 5 equals x. And now you take out your calculator and you get 0.18 equals x. So there we solve for x. Okay. We are going to solve equations involving radicals, square roots, cube roots, etc. The key will be to isolate the radical. So the first thing you want to do when you solve these is isolate the radical. It's similar to this problem because the first thing we wanted to do here was isolate the little exponential phrase, the e to the x. So very similar. Here, the first thing we want to do is isolate the radical. And then we will find x. So here we go, example 1. We have the square root of x plus 1. That's what we need to isolate. So I'm going to add 5 to both sides. So negative x plus 1 equals negative 11. Now I need to get rid of that negative sign. So I'm going to multiply both sides by negative, and I get positive x plus 1 equals 11. And now I square, hold on, there we go. Now I'm going to square both sides. And you've done this before, of course. So x plus 1 equals 11 squared, which is 121. Subtract 1, and x equals 120. You always need to check your answers right here. Beware of extraneous solutions. Always check them. You can just mentally check them. What you're doing is you're putting in the value for x into that radical, and you're making sure, first, that you are not going to take the square root of a negative, and second, that it is truly a true equation. For example, if you can just do this mentally if you want, but you'd say, okay, 120 plus 1 is the square root of 121, which is 11, right? So here we have negative 5 minus 11. Does that equal negative 16? Yes. So just make sure you check your solutions. All right, B. Here we go. This is a cube root. We need to isolate it. So I'm going to divide by 8. So that's the cube root of 5x minus 7 equals 12. Now I will cube both sides. So on the left, I have 5x minus 7. On the right, I have 12 cubed, which is 1728. And now I solve for x. So I add 7, so 5x equals 1735. Divide by 5, and x is 347. Get out your calculator and check that. 5 times 347 minus 7 cubed root times 8, and that equals 96. You need to check your answers. Okay, now this equation, the radical on the left is isolated and the radical on the right is isolated. So this one's not so bad. All we're going to do is when you have radical equal to radical, you are just going to take both of those. Since it's both the same index, it's really nice. You can just raise them both to the 5th power. And that would undo the radical on both sides. So look at there. These are the nicest ones to solve. And we have that equation. And now we get our x's together. We move our 1 over, and x equals 5. Again, check your answers. So 4 times 5 is 20 plus 9. So this is 29. 6 times 5 is 30 minus 1. This is 29. That's a true statement, so we're good. All right, now this one, the left radical is isolated, but the right radical is not. It has that 3. But there's nothing you can do about that 3. You could divide both sides by 3, and then you would just have the 1/3 over here, right? So that doesn't accomplish anything. You cannot get rid of that 3. So what you're going to do is you are just going to raise everything squared, but you also have to square the 3. So the square root of 7x plus 2 squared is 7x plus 2. The square of 3 is 9. And the square of the square root of 3x minus 2 is 3x minus 2. So be careful there and make sure you make that a 9, and then you proceed to solve it. So you have 7x plus 2 equals 27x minus 18. You'll get negative 20x equals negative 20, and x equals 1. Check it. So this is 7 times 1 is 7 plus 2 is 9. Square root of 9 is 3. Here we have 3 minus 2 is 1. Square root of 1 is 1 times 3 is 3, so it works. Okay, next. Now we have this equation. Let's solve the equation algebraically. So let me show you what we're going to do. What we have here is our square root sign is already isolated. So we are going to go ahead and square both sides of the equation. So I'm going to square that, and I need to square this. Be very careful here. You need to put those parentheses, and you need to FOIL out 5 minus x. So what we have then on the left, whoa, hold on. Okay. What we have on the left will be negative 3x plus 33, because the square and the square root sign cancel. But on the right, we need to FOIL this. So make sure you FOIL correctly. You have 25 minus 10x plus x squared. And so now we have a quadratic. Solving the quadratic means that we're going to put everything equal to 0. So since my x squared is positive over there, I'm going to go 0 equals x squared comes first. I had a negative 10. I'm going to add 3. That gives me a negative 7x. I had a 25. I'm going to subtract 33. That gives me a negative 8. So there's my quadratic. Now I try to factor it. And I have x plus 1, x minus 8. Therefore, x equals a negative 1 and x equals 8. Now, let's check those answers. All right. So I'm going to go over here. I will put negative 1 in first. So I have the square root of negative 1 times negative 3 makes 3 plus 33, which is the square root of 36, which is 6. When I put negative 1 over here, I have 5 minus a negative 1 makes 6. So we're good. That one works. Now let's try it with the 8. The square root of negative 3 times 8 is negative 24 plus 33, which is the square root of 6, 7, 8, which doesn't really simplify. On the right, did I do my math right there? Let me just check it. Negative 24, 6, 7, 8, that's a 9. There we go. All right, and that would be a 3. But on the right, when I put an 8 in, 5 minus 8 gives me a negative 3. This is not true. This is extraneous. And so we toss that out and we only have one answer. X equals negative 1. All right, solve the equation graphically. So now what we're going to do here is I am going to, I'm going to pull up my calculator. But before I do that, remember how to solve this graphically. You're going to say, well, y1, since it's an equation, you do y1 equals the square root of negative 3x plus 33. y2 is 5 minus x. I'm going to put both of those into my graphing calculator. So pulling that up, get a little bigger, clear, y1, you should all be doing this. Second function, square root, negative 3x, x plus 33. y2 is 5 minus x. And I'm going to graph it. And I'm going to make my window a little smaller. How do I want to make it smaller? It goes out. Hold on, I just have to think a minute. I want my x minimum to be only negative 3. Let's see if I can see better there. Nope. Oh, I need to make it bigger, not smaller, you silly students. And we need to go down lower, so we'll make it negative 15. Let's see if we have better luck there. There we go. Okay, so what you see there is you see the blue line. There's no bottom. Like, you know, normally it would go like, here's my y-axis, it would go like this. But because it's a function, your calculator's making it a function, of course, so it's not putting a bottom blue curve on there. And that bottom blue curve, here's my, so there's, this is this portion right there. And then this portion, it keeps flopping away, goes right through here. And this graph is linear, and that's right there. And so right here is what we want to notice. This doesn't exist. And look at there. That's where that positive 8 solution would have been, right there. This solution right there is x equals negative 1. Cool? So you can note, what you want to notice here is that the domain is restricted to make it a function. So it is, quote, missing other half. Which we found right there. It doesn't work. We toss that answer out, and the bottom half of the equation doesn't work. So if you would solve this equation algebraically or graphically, you're going to get the same answer. Cool, huh? All right, C. How can you determine that you have an extraneous solution without having to graph the equations like we've been doing? Oh my goodness. You check solution in original equation. You look at domain. You do not want to take the square root and radical, which is a radical, but any even radical of a negative number. All right, moving on, number 3. All right, we are doing the same types of problems here, but this time they're written differently. Remember, these denominator exponents just mean the radical. So A could be written, if you wanted to, as the cubed root of 5x plus 7, you don't need those parentheses, equals 3. These are the exact same equation. To be honest, I think they're easier to solve with the little rational exponent, because sometimes these rational exponents get a little more complicated. So what you're going to do here is you want to make sure it's isolated, which it is. This radical is isolated. So now I'm going to raise everything to the reciprocal exponent. So that means I raise it to 3 over 1, which is just 3. So on the left they cancel, and I have 5x plus 7 equals 3 cubed, which is 27. So 5x equals 20, and x is 4. Again, check for extraneous solution. So 5 times 4 is 20, plus 7 is 27. The cubed root of 27 is 3. It works. Okay, here we are. This time, here's my little radical expression, or my exponential expression. So I need to isolate it. So I need to move my 1/2. So I multiply both sides by 2 first. And now I'm going to take each side of my equation to the reciprocal exponent. So that means I square the left and I square the right. What do I get on the left? I get 8x squared. No, I don't. I get 4x squared. And on the right, I get 4x plus 8. So now I can see I have a quadratic. So I'm going to set that up. 4x squared minus 4x minus 8 equals 0. I'm taking out that 4. And the reason I can get rid of that 4 is because I have it equal to 0. I'm dividing that 4 out, and I still keep 0. Factoring x minus 2 plus 1. Therefore, I have two solutions, x equals 2 and x equals a negative 1. Check both of those, and you will see negative 1 does not work. And so your answer is x equals 2. The reason, by the way, negative 1 doesn't work is you put negative 1 in there and there. Well, you would say this radical equals a negative, which it doesn't. So there you go. All right, next one. Step 1, here is my exponential or radical expression. I need to isolate it. So I'm going to add 3, which means I have negative 14x plus 2 to the 1/2 equals negative x plus 3. And then I still want to get rid of that negative sign, which means I have negative 14x plus 2 to the 1/2 equals positive x minus 3. And now I will raise both sides to the second power. So that means I have negative 14x plus 2 equals, again, you have to FOIL that. So you have x squared minus 6x plus 9. Again, you have a quadratic. So 0 equals x squared. Negative 6x plus 14 is positive 8x. 9 minus 2 is 7. Factoring, we have 0 equals x plus 7, x plus 1. So therefore, x equals negative 7 and negative 1. Checking those, when you put a negative 7 in, it will not work. And when you put a negative 1 in, it will not work. They are both no solutions. Okay, by the way, you are welcome. In fact, I encourage you, put those in. See why they're no solutions. Basically, it's because of that little minus sign right there. But you will see if you give it a try that it does not work. Example 4. The time t in seconds that it takes a car to travel a quarter mile when starting from a full stop can be estimated by using this formula, where W is the weight of the car in pounds, P is the power delivered by the engine in horsepower. So the first thing is solve the formula for P. So right now we would say this formula is solved for T, right? T equals, it's solved for T. So now we want to change it and we want to solve for P. So I need to undo this equation. So the first thing I'm going to do is I'm going to divide T by 5.825, and that equals the cubed root of W over P. Now I need to get rid of this cube root sign. So I'm going to cube both sides of my equation, which means I have t cubed over 5.825 cubed equals w over p. And now p is in my denominator. And so I'm going to have to move, obviously, p to the numerator. There's different algebraic ways to do that. One, you could cross multiply. Two, you could just multiply by p and divide by the reciprocal of the left equation or left fraction. But let me just do cross multiplying. I have p times t cubed equals 5.825 cubed times w. And now p will equal 5.825 cubed w divided by t cubed. And there you have it. We solved for p. There we go. And you don't have to clean that up. You don't have to tell me what 5.825 cubed is. Nothing. That's good. Another way to write that same thing would be w times 5.825 over t, all of it cubed. Either one of those is good. All right, moving on. If the quarter mile time for a 3,590-pound car is 13.4 seconds, how much power does its engine deliver round to the nearest horsepower? So we are looking for p. We've already solved for p right here. So we are going to use that equation, and we're going to say p equals 5.825 cubed times w, which is the weight in pounds, right there, divided by time 13.4 cubed. Put that in your calculator, and you should get 295 horsepowers. Finally, here's your inequalities. So we still have problems with inequalities, solving inequalities graphically. So this will be a good review. The first step to solving an inequality is you move everything to the left side. So you're going to say the negative cubed root x plus 1 minus, I'm going to add 10. I'm sorry. I wasn't looking at the problem. I was just talking. Go away, go away. All right. So the cubed root of x plus 1, I'm going to add 10 to both sides, so I have plus 2 is greater than or equal to 0. And it is this right here, this sign, that is so important. It's greater than 0. This is the graph, whatever graph you come up with. And the problem says the graph has to be greater than 0. And 0, remember, is the x-axis. And so basically we're saying, when is the graph above or on? Above or on the x-axis. So let's graph it. Pull up my little graph here. You guys should graph it too, because these still give you problems. So we're going to go up there and we say, I can hardly read that. It's so tiny. Let me make it bigger. Not much better. All right, I'm going to do it this way. Parentheses. I can't see the cubed root on there, so I'm going to put it in rational exponents. Negative. And I already messed that up. Hold on. We'll get my act together here in a minute. They're still blurry. I don't know if they're blurry for you, but they're very blurry for me. Negative, parentheses, x plus 1, parentheses, raised to 1 divided by 3. So that's the cubed root right there. Plus 2. All right, there we have it. So now I want to graph it. And there we go. So you can see, I don't know if you can see my cursor here. This is my 0. Whoa, I can't touch it. This is my 0. Now remember, our question is, when is the graph above that? That would be all of this. When is it below it? Way over here. So I need to find that 0, which you guys know how to do. We do second Second, calc. Find your 0. Not your minimum, your 0. Enter. Put the cursor to the left of the 0. Enter. Put it to the right. Are we down? Yep. Enter. Estimate. And the 0 is at 7. So I'm going to get rid of my graph. Here it is. It went like this. Sort of like. Here is the 0 at 7. Now the graph or the problem says, when is the graph above or on the x-axis? Well, it is above or on the x-axis here to here to here, and it includes 0 right there because it has that. So therefore, how do I say that? Well, x, in order to be above, we're to the left of 7. Therefore, x has to be less than or equal to 7. There's my answer. So notice that this sign here is not the same as this sign here. The sign changes. This sign here tells me what I'm shading on the graph. And once my graph is shaded correctly, then I have to analyze the graph, and I say, for what values of x is that true? And this would be x is less than or equal to 7. Next one. We need to get the right side of our inequality 0. So I'm going to say that square root of 2x minus 6, subtract 9, and I have minus 6 is less than 0. So what does this mean? This means right here, here's my graph, my line, whatever it's going to be, and I want to be less than 0. So we want to be below the x-axis. We're not even on the x-axis. There's no equals. It's just below. So now stick it in your graphing calculator. You're going to do it this time. And notice this is a square root graph. Remember we said those even root graphs, they always have a starting point. And so you have to find two things here. You have to find this point. That's the starting point of the graph. So you need to know where your graph begins to be defined. Then you also need to know your 0. And your 0 is at 21. So this graph is not drawn to scale at all. But the solution here is going to be everything below the x-axis. So I'm below the x-axis here. It's not on 21 though. There's no equal sign. So now I've used this portion, and now I just need to analyze it. And the question is, for what values of x is the red shaded true? And that would be when x is less than 21. It's to the left of 21, but it is to the right of 3. But it can equal 3. And there you go. So this includes all this, but not 21. And there's my answer. And that's the end of the video.